What's up, guys? Welcome to part 5 of the Metasploit Mega Primer. In this video, we will try and understand more about Windows security, Windows tokens, impersonation, etc. And then look at how to use the Meterpreter Incognito extension. Right, so the Incognito extension is a very powerful extension and can steal Windows tokens and impersonate them. But before we get into all that, we need a quick primer about the Windows security model, tokens, impersonation, etc. Okay, so every user on a Windows system has a unique ID called the security identifier or SID. Now, the SID is of the form S-revision level, which is 1 till now. After that, identified authority value, which could be the local system or a domain controller. Then you have a domain or a local ID, which is a variable part, and then finally a relative ID. Basically, the SID is going to be unique for every user on the system and in the domain. Right? Now let's move on to understanding tokens. Well, when a user logs into a Windows system, there are a lot of processes created on his behalf. For example, explorer.exe, etc., which helps in running the desktop. Now, what Windows does is based upon the user who has logged in, it goes ahead and gives a primary token to the user process. This token contains the SID or the security identifier, various group information and privileges which the user who's logged in is allowed to do, and a lot of other info. Now, interestingly, what happens is when this same user process goes ahead and creates multiple threads, each of these threads are also given the same primary token associated with the user. So where is this primary token exactly used? Well, think of the primary token as an authorization evidence. So whenever one of the user processes or its threads want to access a resource or operation which requires certain privileges, then the primary token is taken and compared to the privileges requested. If the token has sufficient privileges, then it is allowed to access the resource or the operation. Very simple concept. So think about tokens as authorization objects which are given to user processes and which they use to show proof whenever they are requested for privileges by some other entity. Okay, what are impersonation tokens? Well, very simply think about this case that there is an FTP server process running on a system. Now, this server process would have a primary token associated with it based on which user started the FTP server process. Now, this could be the system account, the network service account, or any other account which the admin might have set up. Now, each one of the threads of the FTP server process, let's say, is being used to serve an individual client who connects remotely to the server. Now, as in the previous slide, each one of these threads also possesses the primary token of the FTP server process. Right? So now let's say when the first user logs in, what happens is the FTP server needs to go ahead and access various resources and file systems which user 1 has authorization to access. Now, it cannot do that using its own primary token simply because its token might not have all those access privileges. Hence, it needs to somehow assume the identity of user 1. This is done by going ahead and creating an impersonation token for user 1. Now, thread 1 uses this impersonation token, which is created after user 1 authenticates using his credentials. And then using this impersonation token, thread 1 is able to access anything which user 1 is allowed to access. Similarly, user 2 and user 3 would log in, and the different threads servicing them would obtain impersonation tokens using which they are able to access resources for all of these users. So very simply put, impersonation token is a mechanism by which temporarily a process or a thread can assume the identity of some other user on the system, and this is different from the user creating the process. And once they're gone ahead and serviced requests for this impersonated user, they go ahead and relinquish this token and go back and assume their primary token, right? Very simple concept. So what are the different levels of impersonation token? Well, the basic one, which is just impersonation, allows the server to act on behalf of the client, which is the user, but only on the local machine on which the server is running. Typically FTP, SSH would be examples. Impersonation tokens are actually created through non-interactive logins. The other is delegation level impersonation tokens. Now these are very powerful because here the impersonation can extend even to remote systems on which the authentication credentials passed by the client are valid, which might be in the same domain or an extended domain, right? Delegation level tokens are generally created using interactive login, such as somebody logging on the console or using terminal services. But what are the attacks? Right now we've looked into a lot of theory about tokens, impersonation tokens, primary tokens, how they work. But what is the actual problem? Well, here is the issue. The first attack is called local privilege escalation. Let's quickly look at how this works. Now, let's say there is a server process running with very low privilege, but this server process is servicing different users on the system. Now, let's say the admin logs on using his credentials to the server process, and one of the threads of the server process gets the impersonation token for the admin and is running on his behalf and doing various tasks. Now here is the problem. What if an attacker breaks into the server process by using an exploit or some other means? Because if he successfully does so, then he will have access to the process's memory space, using which he can actually get the impersonation token for the administrator. Once he does that, he can go ahead and run commands impersonating the admin, right? A typical example would be a SQL server where one may connect as admin using Windows auth, even though the SQL server itself might run as a low privilege user. But when an attacker subverts the SQL server, then the admin's token might still be available in memory, right? And which the attacker can use and assume the identity of the admin. So this is the local privilege escalation attack using impersonation tokens. The second is domain privilege escalation. Now this is a bigger problem and a bigger attack. What could happen is once the attacker breaks into a server process which actually contains an impersonation token with allowed delegation for an admin, then the hacker could take that token and actually log on to other systems for which the admin is responsible for administrating. Now, one of the best starting points to get such an impersonation token with delegation would be the admin's own workstation. Okay, a lot of theory. Let's now go and have a quick look at a demo with Incognito. Right? So let's exploit the remote system. This is the Windows box, which we have seen so many times already, right? So we are just about to get a Meterpreter shell. Awesome. Now by default, the Incognito extension is not loaded. We use the use command and load Incognito up. Once we do this, we will notice that the different commands available with Incognito are displayed. Let's quickly do a get UID to figure out who we are. So we have broken as a system account, which is great. So the first thing we will need to do is list all the tokens available under the current user context. So this is done by using list tokens. We can give it two options to list by unique username or group name. Let's give it unique username. Awesome. If you notice, we have so many delegation level tokens available and just one impersonation token available. So what can we do with this? Well, before we steal the token and impersonate, let's actually first ensure that even a shell access on the system would give us the same thing. Okay, who am I unfortunately doesn't exist on this XP system because it's a very old one, and who am I was only made available after service pack 2. Awesome. So this actually tells us that we are the system username, right? Let's exit from this. Now once again, let's go ahead, list all the tokens. Now what we will do is impersonate a token by giving it the actual token name. You need to enter on backslash because Meterpreter has some parsing issues, I guess. Great. So successfully impersonated user. Now if we do a get UID, you will notice that we are the user Vivek on the system. You can verify this by getting a shell and once again using an echo username command. Awesome. Displays that we are Vivek. Let's exit. Now one interesting thing you will notice that if I do a list tokens right now, after I have impersonated as the user Vivek, no tokens are displayed. Well, this is because we are not running with sufficient privileges to be able to see system-wide tokens. So Meterpreter is actually telling us we can use rev to self, which is revert to self, and actually bring back our system privileges, right? So we can use rev to self, and now we are back to our system prompt. Now one of the other quick things you can do is hit PS, look at a list of all the processes running and the usernames they're running under, and then go ahead and use the steal token command, which is available with STD API, and mention the PID of the process. Now if let's say the PID of the process 2024 is explorer.exe, which is running under the user account Vivek. Now steal token 2024 will actually go ahead, inject itself into explorer.exe, steal the token of the user Vivek. Awesome. Let's hit a get UID again, and now if you notice we are Vivek, right? And hit rev to self and get back to who we were. Great. So this is an example of how we can go ahead and steal tokens once we have broken into a system and assume different identities on the system. Once we assume different identities, there are various files and tasks we can do based on the new identity we have assumed, right? One thing which I'm not demoing right now is the actual domain level breaking using delegation tokens. This I will show in a later video in an attack called pass the hash attack and how all this is done. Great. So coming back to the presentation. Well, that's all I had in mind for part 5. Hope you enjoyed it. I'd really request you to please leave a comment behind so that I know how you find these videos and whether I should continue making these videos or not. It's your encouragement which keeps me going. Well, that's all for this video. Thanks a lot. Have a great day ahead.